Let us start today's session. Good evening, everyone.
Good evening.
Uh, We'll start with today's session. This is week 5 live session for Smart Grid Basic to Advanced Technology NPTEL course. My name is Gagan Meena and I'm TA for this Monday live session. Okay. So I hope the way we are going through these sessions is helping you. If you have any kind of suggestions, you can always provide your suggestions. Do you have any doubt in previous weeks?
No.
Okay. Okay, so let us start with today's session. Before that, just a reminder about submitting the assignments. The deadline for assignment 5 is February 26th, and for assignment 6 is March 5th. So please submit them on time. And this is the link where you can find the recordings for the live session. Okay, we'll start with the overview of week 5. In week 5, the main topics which were discussed were the islanding detection techniques for microgrid and introduction to protection in smart grid or smart grid protection, different challenges which are there because of increasing penetration of renewables. If we talk about microgrid, then microgrid can be of different types and they can be classified into different types based upon different criteria. And if we see about the point, first classification starts with the size. Depending upon the size of the microgrid, there can be very small microgrids less than 10 kilowatt, between 10 to 1 megawatt, and more than 1 megawatt. This classification is given in this paper, which is this comprehensive review of microgrid protection and protection challenges and mitigation. If you want to go into details, you can go through this paper. And some of other slides are also based upon this paper. Then there can be another type of classification based upon the area which is covered by this is also size, but it is based upon the geographical area which is covered by the microgrid. If let's say this is the substation from where the main grid is connected, and then there are different feeders. These are different feeders. And in one feeder, you can have different laterals. Several laterals are possible. Let's say this is one house, and here we have loads and DER is there. There can be storage also. If we talk about this, then it's a single customer microgrid. Here one breaker is there. Here's one breaker, and this is one lateral of this feeder. And it can have another microgrid. There can be different types of resources here, also energy storage. Then fuel cell or synchronous based DERs, distributed resources, or then there can be inverter based DGs or DER. If we talk about this microgrid, and there can be number of houses here, lateral. And this is a partial feeder, a part of this feeder. Let's say this is feeder one, and this is feeder, say feeder four. So this is a part of this feeder. It's a partial feeder microgrid. Similarly, if we consider this feeder and this entire feeder, then it will be full feeder microgrid. Entire feeder is considered as a microgrid. Even there can be this hierarchy also. A single, all these type of microgrid can coexist. And what's the advantage of that? If there is a fault here in this lateral, then only this single customer is out of. This will be not connected to the feeder. But still, because this single customer is also a microgrid, there are certain resources. Solar PV is there, energy storage is there. Still, the certain number of load or a percentage of load, or even full load, depending upon the size of the DGs, the loads can be supplied. Similarly, each of these section can be a microgrid, and this increases the reliability and ensures uninterrupted power supply. If this entire feeder goes away, still this entire feeder, if there is a fault in this here, then this entire feeder, or let's say there is a fault here, the fault is here or somewhere on this, let's say this main lateral, then this entire feeder will be disconnected from the substation. But still, because this entire feeder is a microgrid, it will be self-sustaining. Similarly, this entire substation can also be another level of microgrid. When there is a fault on the main grid side, this entire substation will be disconnected from the main grid, and still it will be able to supply quite significant amount of load because it's a microgrid. This is one type of classification, and then based upon configuration that we will see in future weeks, maybe ninth week, eighth or ninth week. Different types of configuration are possible. The AC microgrid, the conventional system which we have is AC. So if we have a microgrid in that, then it will be AC microgrid, completely AC supply, and all the loads are, even if the DC loads are there, then converters are there too. For example, can you give some example of DC loads? It's loads which require DC power supply, and we are still using them. Although our distribution system is having AC power supply, but those loads actually require DC power supply. Can you give example of such loads? Any one example? All these uh, electronic devices that we have, electronic gadgets, especially those which work on batteries. rechargeable batteries. For example, laptop, mobile, all these batteries they require DC power supply. But in the charger, there is a converter, AC to DC converter, or rectifier is there. But because the supply from the grid is AC, we need to have that stage AC to DC conversion to charge that battery. Electric vehicle is another example. But if the DC grid is there, DC microgrid is there, then that conversion stage is not required. Directly we can charge the battery. We might be one conversion stage might be DC to DC chopper or some buck converter might be required to so the DC microgrid voltage level would be more than that which is required by the charger, that mobile charger. So one is AC, DC. Then there can be a hybrid of AC and DC because we have sources which are both AC and DC, and loads also which are both AC and DC. If we have a hybrid where DC loads are connected on the DC sides of microgrid and most of the AC loads are connected on the AC side of the microgrid, then this efficiency can be improved. It's not always possible to have completely all the AC loads on the AC side, but still we can have majority of loads on the AC loads on AC side and DC loads on DC side. That way we can improve the efficiency. So that is the third combination, and we will see that when we will talk about control of different control techniques in microgrid, distributed control, hierarchical control. There we will see these different configurations of microgrid. Then there can be, this is another classification which you already know. In distribution system, we have different types of customers: residential, industry, commercial, or agricultural. Then based upon mode of operation, there are total three modes possible in the microgrid. So one is grid connected mode, when the microgrid is connected to the grid, to the main grid. And this is the main grid, and we have a circuit breaker here, and then there is another feeder here. Then here can be some loads. The most simplest. And there can be loads, battery also. And so if this circuit breaker is on, then this is in the grid connected mode. This is a microgrid. This is a microgrid. If this circuit breaker is on, it is grid connected. If it is off, then it is islanded. And third mode is when it is transitioning from, is a transition from grid connected to islanded and vice versa. From islanded to grid connected. That is a transition mode. Okay, then based upon sources, we can have different types of sources. Only having renewable, with this which I drew right just now. If what type of microgrid would this be based upon sources? This is a synchronous based teaching. So can you tell? Is it a renewable, non-renewable, or a hybrid microgrid? It's synchronous based distributed generator. This is inverter based DG. Anyone? What type of microgrid is this? Renewable, non-renewable, or hybrid? Nobody? So, this is inverter based DG, so this is has to be renewable. Let me share this again. Meanwhile, can you tell which type of microgrid is this? What do you think? Any idea? Any guess?
Screen is not visible.
Hybrid? Yeah, I'm sharing. Actually, says hybrid. Wait, I think I should not use my laptop. Every time it hangs. Now I'm shifting to the desktop. Just every time sharing the slide. I hope it's visible now. Is it visible?
Yes.
Okay. Yeah, so I was saying uh, yes, I drew one picture. So I was asking if this is a microgrid, and this is synchronous based DG, and this is inverter based DG. What kind of a microgrid is this? based upon the type of sources. Is it renewable, non-renewable, or a hybrid? Some of said it's hybrid. So that is correct because if nothing is mentioned about SPDG, so SPDG can be a renewable source resource also. It can be non-renewable also. It can be diesel generator, gas and turbine, or even a micro turbine. So it can be both uh, renewable and non-renewable. So it's a hybrid because we have one inverter based. This is renewable and this can be renewable or non-renewable. So it's hybrid. Okay, we'll move to the next part. This is another type of microgrid classification. One is this is AC radial AC radial type microgrid, and most of the distribution system which we have presently is although there are meshes, few meshes to increase reliability, but the operation is in radial mode. This is radial, and this is a mesh, AC meshed type microgrid here. The next, as I had mentioned, that these are the two main topics which were discussed in this week. First was the anti-islanding detection techniques, and then next one was the smart grid protection. Why do we need the islanding techniques, and what are the different types of islanding techniques? Here we discuss what is the necessity of islanding detection and the different types of islanding detection techniques. And then what is the non-detection zone? And this we already discussed that microgrid can have three modes. One is grid connected mode, another one is islanded mode, and third one is the transition to island and reconnection mode. Okay. This is if the islanding, unintentional islanding. Islanding can be of two types. One is intentional and another one is unintentional. These are the two types. Intentional islanding is first is unintentional, which is without any planning. It is forced, just as we have forced outages of generators. It is not planned, it is unforeseen, and it happens without any prior information. That can be from main utility grids or independent power producers. And this can be because of so many reasons. Faults at the main utility grid can be due to some system failure on the grid side, can be due to human error or some natural disaster. Can be due to cyclone, earthquakes, so many things. And then one is intentional, which we are doing it systematic. It's a systematic separation of the main grid to avoid any major breakdown. Okay, so this can be due to avoid or overcome blackout and cascading failures for system maintenance. So, when maintenance has to be done, we isolate the part of the grid. In distribution system maintenance, you will mostly every year there are annual maintenance. Even in between there can be maintenance, but during Diwali break we will see before Diwali they will every year they do maintenance because Diwali time no one wants to have load curtailment, right? Everyone wants to decorate their house, so the maintenance is usually carried out at that time. And then to avoid load curtailment also, to do load curtailment, intentional islanding can be done when sufficient generation is not there to meet the load demand. And then another reason is to prevent the equipments on the microgrid side because of faults on the main grid side. If we are unable to detect these islanding events, and there can be several problems. Like it can be a threat to the safety of person who are working. Because let's say if there is a fault on the main grid side, and the people are so there is a fault on the main grid side, and those who are working here to isolate to to mitigate the fault, and they don't know that this circuit breaker is open, or the circuit breaker is still open, and they don't know that there is some power supply from the this microgrid also. If they don't know the status of that interconnection, then it can be hazard to their life. Because once they know the status, if they know the wrong status and they are working on this side, then their life will be in threat. It will be in danger. So whenever they have to do any kind of fault isolation, then they have to ensure the grounding on both side of the conductor. Let's say this is the section of that feeder. Then they have to ensure that both the side their grounding chains are there. Even though this side is disconnected, but due to some human error, if it still it is connected, let's say due to some human error or miscommunication, this the line was still connected. Then if the person is working, then it will be a problem for him. That's why first of all they will ensure that they put these grounding chains on both the sides so that both the sides are grounded and they can safely work on this feeder, this segment of the feeder. Then there can be problem with the inverter control mode switching. Depending upon the mode of operation, the status of the circuit breaker, the inverter control has to be there. The converter, because most of the converter that we have are grid following, and their operation depends upon the voltage and frequency reference which which is taken from the bus at which they are connected, or the point of their common coupling. If there is a fault and this has to be disconnected, then the voltage and frequency reference is not there. Or if it is disconnected, the voltage and frequency changes here. And based upon that, the control needs to be changed. Similarly, there can be damage to the protective devices or the failure of the protection system also. We will see what are the challenges in the next slides. Yes, so that's why we need to change the protection philosophy depending upon the mode of operation of the microgrid. And for that, we need to know the mode of operation of the microgrid. And the microgrid, there are local and central controllers, and they need to communicate with each other the status of circuit breaker so that the protection philosophy can be changed whenever the mode of operation changes. So these are the different types of islanding detection techniques. These are intentional islanding detection techniques. which we want to know when we want to isolate the system because of faults or maintenance or any kind of load curtailment. Even though load curtailment is there because it's a microgrid, we can still supply the load, but we need to know the status so that the inverter can change uh, their settings, and even the protection system can change its settings. Otherwise, it will not be able to work properly, and the relays will malfunction, and the coordination between the worker and relay will not be proper. That's why it's very important to know the status, and for that we have these in different types of intentional islanding detection techniques, out of which first category is the passive islanding detection techniques. And these are also of different types. Like first one is conventional, then signal processing based, and third one is the AI based techniques. So these here the conventional techniques, for example, some quantities are measured, one quantity, different types of quantities can be measured, and if those quantities are above a particular threshold, then it is detected that there is islanding. In normal operation, those quantities will be below that threshold. But as soon as there is islanding, these quantities change. For example, the rate of change of frequency, the rate of change of phase angle, the rate of change of power, this rate of change of uh, superimposed negative sequence voltage and or superimposed negative sequence impedance, then under frequency over frequency relay, and then it can also be based upon the detection of different power quality metrics, or even the detection of impedance. Impedance also changes whenever there is a shift in the mode from grid connected to islanded, and voltage balance. Let's say there is a fault in one of the phases. There are three phases and one phase there is a fault. And what will happen? The current in that fault will reduce. But in other phases there will be impact of that, and because one phase current is reduced, the system becomes unbalanced, and because of that the voltage unbalance will increase. Although in distribution system there is an inherent unbalance, but whenever there is a phase, the unbalance will increase, so voltage unbalance will increase in that case. Okay, so this is the most basic conventional technique. Here the advantage is that it is economical and there is no power quality issue here. But the problem here is larger non-detectional zone. Minimum 15% of mismatch. So for that, let us see what is the power mismatch. So this NDZ non-detectional zone, it depends upon the power mismatch. Power mismatch is equals to difference between the load power and the DG power, power supplied by the distributed generators. So P load minus the power supplied by the distributed generators, that is the mismatch power. And if that mismatch is below certain level, then the relay is not able to detect that islanding. And that zone is called the non-detectional zone. It's a problem with MS Teams. I'm not able to move the slides. Just a minute. I hope slides are visible. I think I should not use the slideshow mode. I will not be using slideshow mode. Sorry for that. There is some problem. I don't know what's the problem, but that's every time in slideshow mode it is creating problem. Okay. Now I'm using PDF version only. I think it's better now, right? Slides are changing. Okay. Is it visible now? Sorry for the inconvenience. There is some problem with Microsoft PowerPoint and this Teams together. Something. we will stick with this uh, or Adobe version. Okay, so I was talking about this passive islanding detection techniques, and the basic principle is that we compare these different electrical techniques or parameters which is derived from the electrical quantities measured at the point of common coupling or the DR terminal. And then we compare it with the threshold. And if it is more than the threshold, then we say that it is a lending event. And if it is less than the threshold, then it is not islanding. And these different electrical quantities and parameters are given here. And these can be voltage, current, even impedance, and their positive, their negative sequence values also. Here advantage is that this is very economical and there is no degradation of power quality, which we will see is there in the active islanding detection technique. Yes, I was talking about the yes, I was talking about the mismatch. So P delta P mismatch is equals to P load minus P DG. So this is the power mismatch, and if this mismatch is less than a particular a percentage, let's say 15 percentage for these passive detection techniques, then the islanding is not detected. So this is there for both P and Q. That's why if we have delta P mismatch on y-axis and Q on x-axis, then this is the zone where the islanding will not be detected. This is called as NDZ, and this is 15%. Okay, and for passive islanding detection techniques, this zone is very large. And this is a major disadvantage of these techniques. So this will not work when there is zero power mismatch. But still, and it can happen. Can you tell when can this happen? Although there is islanding, should there be islanding when P delta mismatch is zero? Is it possible? When will this be possible? Although islanding is required, but mismatch is, how can mismatch be zero? Can use this equation then. When will the mismatch be zero? Can you tell? If although the microgrid is islanded, but if the load is equals to the generation or the generation is equal to the load, then mismatch will be zero. But we want to island, yes, zero. Not zero import. Zero import means we are not connected to the grid. That means the the microgrid is islanded. We can be, no, we can be floating. Yes. What do you mean by floating with the grid?
Yeah, floating means zero import. We can be floating. just no import, no export.
Yeah, but in that case, it is not islanding, right? The microgrid is connected to the grid. We are talking about the case where uh, grid, the microgrid is islanded from the main grid. Microgrid is islanded, but still the mismatch is zero.
So mismatch is zero, no? If you island in such condition,
Sorry, mismatch will be
zero, no? If you island in such condition.
okay. You are saying when entire load is being met and you are not taking anything from grid. In that case, if there is islanding,
Correct.
yeah, that
Correct.
is
Correct.
correct. Correct, correct. You're right. So that will happen when the microgrid, the generation resources within the microgrid are sufficient to meet the load. Correct. In that case, the mismatch will be zero. And these passive techniques will not be able to detect this type of island event. And so that's why one technique is there which has been introduced to improve. That is also a passive technique, and it is based upon the rate of change of negatives sequence, superimposed negative sequence impedance. Superimposed negative sequence impedance. So here what we do is we can, in the last class we saw, we have seen this DFT technique, right? Discrete Fourier transform for phasor estimation. What we can do, we can measure the voltage, all the three-phase voltages and current VA, VB, VC. Similarly, IA, IB, and
Yeah,
IC
but
from
fundamentally, sorry,
yes,
I'm interrupting. Fundamentally, we do check the breaker status. That is sufficient to say if the grid is islanded or not. So these all things
oh,
come after that. If we are connected to grid and then we have a DF by DT or we have a under voltage, over voltage, and all those things, or a DOC direct overcurrent with under voltage. So then is this condition. But if your breaker is open, then you don't need, no. If the breaker is open, you are islanded.
yes. So breaker status, that for that we require communication. In distribution system, we don't have that much communication right now. And that's why this is the last category. This is also one of the technique which you are saying is communication, and this is based upon the communication between of the breaker status from the transmitter to the receiver, and it is based upon the breaker status only. What you are saying, but for that communication infrastructure is required, and the distribution system which we have right now, the communication infrastructure is not that. There is no communication, you can say. That is the main key for all these things, right? That is why these three techniques are there. They don't require communication. Is this
Okay.
clear?
Okay.
Yeah.
Yeah. Okay.
The communication is certainly that's the most easy. This would be the most. That's why we were talking about this PMU, right? PMU, VAMS, SCADA, VAMS, PMU. So communication uses those SCADA and PMU data. But in distribution system, we don't have that. That is the problem. And that's why we are talking about these techniques, these passive, active, and hybrid techniques. Once we have the communication structure, infrastructure in place, we can use the DPMU or SCADA based. Without that, how we can do based upon these by measuring these different quantities. Okay. Yeah. So yes, we were discussing this. Now we have voltage all the phase voltages and current measurement, and based upon that we can do their DFT also, discrete Fourier transform, and we can get all these three phase these phasors, voltage phasors and current phasors. And from these phasors, these are phase quantities. From this we can calculate the sequence components V120, I120, right? We know that transformation matrix is there. Using that we can calculate the negative sequence, because here we want rate of change of negative sequence impedance. So what we can do before the islanding, we know the voltage, the negative sequence voltage, and negative sequence current before the islanding. And if we take the ratio, then it will be Z2 pre, the negative sequence impedance before the islanding. Similarly, after the islanding also we can calculate this V2 I2 post. This will be Z2 after islanding. And then we can take the difference post minus pre and divided by the time. It will be uh, whatever difference is there between the two samples. That way we can find out this. It will be in ohm per second. This is delta Z superimposed. Superimposed means we are taking the difference between the two. Now one may say that we don't even know what's the islanding instant. Then how do we know that this is pre, this is post? So we saw that we how to calculate that DFT recursively or iteratively. We keep on moving the window and we calculate the DFT. So here also we can do the same thing. Calculate this Z for each window and take the difference. Whenever the difference will be, whenever the difference shoots up, we can tell that this is the instant of islanding, and we can we can change the settings. Whatever action is required, we can do. Okay, so this technique, the rate of change of negative sequence impedance technique, it works even for 0% mismatch in the power. This is also a passive technique, but still it works for this 0% power mismatch. So it's an improved version of these techniques. But it also, the problem here is how to decide the threshold. Now we have found delta Z. Now we need to know the threshold. We need to set a threshold beyond which we will accept the event as islanding event. Okay, so that threshold calculation requires a lot of simulation, and it also changes based upon the sampling frequency, because this denominator will change based upon sampling frequency, right? The difference between the two samples. What is the time difference between the two samples? It depends upon the sampling frequency. So this measure changes with the sampling frequency. That is one disadvantage. Then another kind of passive technique is based upon signal processing. We can calculate the energy which is stored in the signal.
For this, sorry, I'm
Yes.
interrupting. Impedance, negative sequence, impedance based islanding detection. Why will the negative sequence increase or decrease if say in a system which has a zero import from the grid and it gets islanded?
but it is that I need to think. Yeah, I need to think about that. Why will it
Okay,
be?
second thing is, do
Yeah,
we have a practical relay which is available in the commercial market, which does this kind of uh, uses this kind of protection scheme? Because I
based
haven't
upon yes,
come across this. No, it's rock off and this all is okay, but with over voltage, under voltage, directional over current plus over
yeah,
voltage, under voltage, df by dt, and all those things are all available in
yes,
combinations and all that. But this protection scheme in the relay, I haven't come across. That's why I'm asking you.
based upon negative sequence components. You're saying based upon negative sequence components, right? Are you there? You are saying based upon negative sequence
Yeah, yeah,
components,
yeah. Sorry,
right?
sorry. Yeah, yeah.
Um,
Sorry. I lost the screen. Yeah, yeah.
okay.
Based on negative sequence component. Yes.
Actually, the relays which we are using right now, which we use, all these are digital relays and they can be configured because
No, no,
the-
no, 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 no. These relays are coming with some functions. So these functions, this I know, this all numerical relays and all that now, digital relays.
yes,
But these relays, I haven't seen this function yet with having this
okay.
negative sequence.
Yeah,
So
but
if
that
you
is
are aware, this is practically available. Even I searched on net, maybe some ABB
uh,
Siemens or any other
yes,
relays
yes.
having MyCom, but I haven't come across that kind of relay which has this kind of
But
protection. Or it's a theoretical thing, or it is available practically.
but it is not difficult to implement, right? Because we don't have to do anything. Everything is available. We already have all the voltage phasors. We are doing every same thing. We are just simply one step which we are adding is this calculating the sequence component, which can be easily calculated based upon the available phase information. Just this, if it is not available, it can be easily added. It is not a
So
big
theoretically,
addition.
yes. Theoretically, yes. But practically, in field, these relays won't be just used just like that. They will be like well proven. And I mean, what also relays are there for this kind of passive for over voltage, under voltage, and all those things? No, rock off and all. They're very well proven and very well designed, and have so many, because otherwise there will be so many glitches in the relay.
Yes,
If you
yes.
just so this kind of thing you cannot implement in a power system.
Hmm.
Um,
Yeah,
so that's why I'm
lot of
asking you.
testing is required before actual
Testing,
implementation.
tweaking, and so many settings are there, and so many
Yes,
errors are there. Those will be corrected, and it will take years together to prove it that it's a reliable relay. So then only it comes to the market, to the commercial level. Otherwise, no one will implement it with if it is not reliable.
yes, that is correct. Mostly we are talking here about distribution system and distribution system. We are not even using these kind of relays. We are only simply using as overcurrent relay. That too in not in each and every distribution system. So yes, right now I also don't know whether practically these are
Okay.
available
You can.
in
Yeah,
field.
yeah. No problem. I will search. We will
Because
proceed.
right
No
now
problem.
in distribution system we are not using these type of relays. That is sure.
No, no. All systems have islanding protection. Be it
Hmm.
distribution, it's a mandate from the grid IEGC.
Okay.
And these system, and as we proceed, towards more RE penetration and all, the grid
Hmm.
becomes more and more robust. It becomes mandatory for everyone to have these kind of
Have
systems.
hmm.
So this under frequency, especially under frequency protection, is there all every in
Hmm.
all the, because it has to be, the grid has a plan that if there is a shortfall in the generation, how they manage. So
Yes.
automatic load setting and all that will be there always. That is all based on under frequency.
Yes, that's
So
correct.
so that includes distribution system also, all discoms, distribution companies. So it will be there, I'm sure. So but this, what you're
Hmm.
talking about, Maybe
Negative
it's
sequence.
it's a better scheme, no? Because for
Yes,
DER,
yes.
I'm not sure, so that's why it's new for me. That's why I'm asking you.
Yeah, no problem. I'll have to check whether it is there in field or not. But uh, it's a, I don't think it is right now available in field. We'll
Yeah,
have
I
to
could
check.
not find it, and if it's it's very sensitive and very nice, then it can be used commercially. So that's why.
Correct. Okay.
And as you said, communication-based systems have this
Yes.
all digital um, circuit breaker communication and all that. It is good, but it has a time delay,
Yes,
and
yes.
that time delay ultimately leads to a load shedding
Mm.
in the microgrid, because there is no time then left, or the frequency starts dipping, or
Mm.
there may be a blackout in the microgrid if till that time we wait and then don't do a load shedding.
Okay, so we
Say,
should
say
have
you
a
need 100.
backup for communication schemes also.
No, backup is fine. Say you have a generation less and you have load more and you're drawing quite a lot of power from the grid. So in
Mm.
case of a loss of the grid, say
Mm.
that loss of the grid will be communicated through the circuit breaker
Mm.
first, and then a df by dt, or whichever way. Um, it may lead to at times a blackout of the, because once the grid is disconnected, you will have to do a load shedding in the microgrid. Without that, you
Mm.
will not survive, or you will have to suddenly ramp up your generation.
Mm.
And ramping up generation again has its own limits.
Yes.
So in this case, the early detection of islanding is very, very important. Communication systems have
Yes.
as you said already, uh, they may be there, may not there. It may have a backup and all that is fine. Also, it will take its own time to communicate.
Yeah, delay is there
So there is
always.
delay will be there. So that delay is very harmful.
Correct. So we can have something which with fast acting devices can, like, storage is there, and if storage is there, it can actually ramp very quickly. But
Yeah,
how
if
much
you
of
know,
storage we
huh?
require for that? A huge amount
Understood.
of
No,
storage
no.
would be
See,
required for that.
now you came to the point where we are stuck. So there can be storage, but it's not so easily integrated. Uh, we don't even mind having gigawatts of storage, but the inverters are very complicated.
Yes,
Yeah. So
that is true.
to detect island, and then to make them work. Now, whether they will work as in which form of mode,
Which
whether grid
mode? Correct.
following or forming mode, this is a myth. I discussed this with many people, but
Hmm.
people say it's possible, but no one is confident, and there are very, very few examples.
Correct. Because so many storages are there, then uh, which storage will take the role of grid farming, and how to decide that, and how would that happen in that such a small time
Yes,
interval?
yes,
That is
yes, yes,
very, that's a big challenge.
yes, correct, correct.
Who will take
As
that role?
on,
Which device will take that role? That
as
also
far as I
control
know,
system has to decide, right? Control
correct, correct.
algorithm has to decide, and if in that also there is a delay, that has to be through communication only.
Right,
That
right,
is
right,
also a problem. Yes, there are many challenges right now.
right, right.
Yeah, yeah, good. Thank you for your inputs. Okay, so let us move
Yeah,
ahead.
thank you.
And then signal processing based, these are some techniques like S transform, wavelet transform. We have not studied this, but just for your information, these are all I think I have taken from this paper only. You can refer this paper. And then different AI based techniques are also available. Here also they have lower NDZ than conventional, but higher signal processing requirement. And here the problem is the data. Not so much data is required, and their accuracy is also uh, question in question. We don't know how much practical data is required for training these data sets, these AI models. Then next one is active island detect islanding detection techniques. Here these are called active because here we are injecting something, either a disturbance or we are taking the input from the PCC and then using it as a feedback. These are the two options available here. And these because we are injecting some disturbance into the system, it will affect the power quality. It will impact the power quality. And if we continuously, if we are doing the same thing, then it will impact power quality. That's why these tech compare it in comparison to the passive, these are not good in terms of power quality. Although they reduce, their NDZ is very small or negligible, but degradation of power quality is a major challenge. And that is why we combine these two techniques, active and passive. So whenever the active will be used first. First of all, one of the measurement will be used to not sorry active. First of all, passive technique will be used. One of the measurements will be used to detect the islanding. And whenever the passive technique is detecting the island, only then the active technique will inject some kind of injection. So this will reduce the power quality issue. Not completely mitigate it because still there is some injection, but it will be only there for a very short duration whenever the islanding is detected. In normal time, there normal duration, there will be no such injection. That's why hybrid is much better than this active. So it has a significant reduction in power quality issues and also better detection capability than conventional. So it combines the advantages of both passive and active. Passive had the advantage of being simple and it had no power quality issues, but because NDZ was high, active complements it by providing very negligible NDZ, but it has power quality issues. So we combine the benefits of both of them and use the hybrid technique. And last one is communication, which we have already seen. It is the fastest and least NDZ, no power quality issue, but very costly and requires communication throughout the system. Okay, so these are the techniques again, just to explain in terms of flowchart. Here we in passive we measure and analyze the parameter at PCC, check it with respect to threshold. If it is more than threshold, then islanding, and if no, then no islanding. But here we have problem with determining threshold, and it doesn't work with zero active power mismatch, and it is also affected by load type, generation inertia, topology of the network, and all these things. Then this is active injection of perturbation at PCC. Then measure that signal at PCC. If it crosses the threshold, then it's islanding. Otherwise, it's not. Then hybrid. Hybrid also you have seen. It will be hybrid will be instead this will not come here. Injection will not happen continuously. First of all, we measure the signal and then if it crosses the threshold, then there will be injection of perturbation. And then again it will check, and then if it happens for a duration, then it will detect it as islanding. Then communication based technology, there is a transmitter at util side and receiver at the DG side. If the signal is received, then there is No islanding. If it is not received, then there is island. Okay, now we'll move to questions. We'll also discuss few points. The one topic which we left right now, second topic was the issues with the protection, the challenges with the protection in presence of DER that we will take after questions. Okay, the first question is microgrid has a load of 500 MVA. It is based upon the calculation of power mismatch. This is, please note the unit 500 MVA and power factor is 0.90. Generation is 500 plus J 300 MVA. We have to calculate the active power mismatch, active and reactive power mismatch both. Both active and reactive power mismatch needs to be calculated. So what will be the answer? Will you calculate? It's easy. Anyone? E. How did you calculate? It's easy. This load is given in MVA. You convert it into P plus JQ form. It will be how much? Is this answer correct? Okay. Is this correct? What about others? What do you think? Is this answer correct? If you convert this load into active and reactive power, it will be 450 plus J 217.95 or 945 MVA. And generation is 500 plus J 300. So since the total mismatch will be load S load minus S generation, it will be minus 50 minus J. It will be minus J 300 minus 217. So none of the answer is correct here. Approximately 83. Yeah. And how did you get 25 megawatt? This A answer?
Would you learn?
Sorry. If you take this power factor as 0.95, then you will get this answer. Okay, what do you say? Is the screen not visible? Exactly. Okay. Is it visible now? Sorry. Yes, so if you take this power factor as 0.95, then you will get answer A. For 0.9, answer will be this -50 minus J, approximately 82.05. Okay, this we already discussed it. Islanding the load may not be equal to generation. It may or may not be. If it is equal, then that mismatch will be zero. Otherwise, we can calculate using this P load minus PTG. So answer here will be C, not A, because it is P load minus PDG. Both will be negative here. Load is less than the generation here. Okay, answer will be C. Then next question is the for positive active power mismatch, the superimposed negative sequence impedance is. Hmm, what will be the answer in this case? For this, you will have to think a little bit. How will you tell this part? Z2 minus Z2 free. So what will be this? Superimpose negative sequence impedance for a positive active power mismatch. Anyone? This means P load is greater than P generation. Active power mismatch. Right? What will happen? What will happen if load is more than generation? Voltage will reduce. And if voltage reduces, then the impedance will also reduce. So Z2 P will reduce. Then superimpose negative sequence impedance will be negative in this case. Is this clear? And
In this, see, normally our understanding is now you say the load is more than generation. So load we divide in active reactive power. So if
yes,
active load is more than the active generation,
mm,
then it would contribute to a frequency change.
yes,
And if reactive power is less
mm,
than the required, then it would contribute to the voltage.
yes.
Is my understanding right?
Yeah, that is true for transmission system. Even in transmission system also, it is dependent upon both voltage and frequency, but dominancy is in terms of frequency. That impact is majorly dominantly seen in terms of frequency change. That change in voltage is very negligible. That's why we say that. But in distribution, this changes. We cannot decouple the both, and it's more. And the power is more related to voltage here. That's why we say V
No,
square
no,
by.
we can decouple. No, say a bus in a distribution. Now, normally all distribution stations have a capacitor bank, and
Yes.
they try to maintain a unity power factor. And
Hmm.
say the active power somehow reduces, is not meeting the requirement, then
Hmm.
the frequency will dip, right? Not the voltage. Because in the lecture also,
No, if load
madam has taken it
increases,
accordingly.
yes.
So this was means not what we follow practically.
Hmm.
I'll have to change my understanding then if this is true then.
So let's say if the load increases, okay, you have maintained the voltage at let's say 1 per unit. At the substation, it is maintained at 1 per unit. Okay, and
Mm-hmm.
even for, let's say at the load end itself, it is 1 per unit, and for that substation voltage has to be higher than 1 per unit to meet the losses in the line. But now, if the load increases, then the current drawn by the load will increase, right?
Mm-hmm.
So the losses will be more in the line. The voltage will dip. That's what happens in these long feeders, rural feeders. The voltage is very low there at the far end. That's why when the number of consumer increases, we need to replace the transformer, or we need to add one more transformer. So when the load increases, to maintain the voltage, we need to again add one more transformer
Yeah,
because the
say at the
current
remote
drawn
end,
is increasing. So that
no,
will
at the
increase
remote
the
end, say you
voltage
have
drop.
a capacitor bank.
Yeah, if we have a capacitor bank, but
Uh,
for a consumer, for residential consumer, we don't have generally we don't have these capacitor
no,
banks. All these are there for a for industrial
commercial
consumers,
for a commercial
commercial.
consumer also, there are capacitor banks. It's mandatory for
Yes,
them
yes,
to put.
they have they for them
Mm-hmm.
because they have reactive charges also, reactive power charges for power
Mm-hmm.
factor
So,
penalty is there.
so
For
my point is,
residential consumer, it's not there, right?
that
Yes.
active power is an attribute of frequency rise or drop, and reactive is for voltage.
No, that's what I'm saying. Active power depends on both reactive power and active power depends both on voltage and frequency. But in transmission system, the decoupling is very prominent. In distribution system, because of the inherent RLC, the nature, the resistive element is R by X ratio is quite large as compared to transmission system. That's why the decoupling is not possible here. So that's why that active power depends both on voltage and frequency. We cannot say that it will be directly impacting more frequency. On the contrary, it is seen that in distribution system, active power mismatch directly impacts the voltage more prominently as compared to the frequency.
If
It's
you
it
consider an
and it has to do
ideal
because of the
situation,
R by X ratio.
yeah, if you consider an ideal situation, so because
Hmm.
for inverters, no, inverters we consider like that. Say, if there is a drop in the frequency,
Hmm.
then the inverter should operate in a P control mode. And if
Hmm.
there is a drop in the voltage, the inverter is supposed to operate in a Q control mode.
Hmm.
So consider now we are complicated. Means if you consider ideal system
Hmm.
on a single bus and just neglect all those things, the transmission losses and those I squared losses and all those things.
Yes,
So
yes.
in that case, on a bus, if
Hmm.
the frequency drops, I'll have to inject more active power in that to uh, to bring it back to the,
Yes,
to
yes.
hold the frequency.
Correct.
And if the voltage drops, because this is the fundamental we use in the industry also for our operations.
Mm-hmm.
If the voltage drops, we
We
have to
we
ensure that
inject the
sufficient
reactive
reactive
power.
power is available.
Yes, correct. We
Okay,
inject
now
reactive
what I
power.
hear from in these lectures is the
Mm.
vice versa. That's why I'm not understanding this. Even in the lecture also, madam has explained in the same way. Uh,
Yes.
it is opposite to what we think. So
Yeah, because what you're saying is correct. That is that decoupling is there in transmission system. Although in transmission system, both P and Q and these four are related together. But the nature of transmission system is such that we are able to decouple it. That influence of voltage on active power is not that much. That is it's because of the nature of the physics itself. But in distribution system, we cannot directly decouple them. Although you are saying that even distribution system, these inverters are designed like that, right? Is it
yeah,
correct? Yes. Yeah.
no, even in the inverters, on like
Yeah.
which have
Even
a fast
inverter.
frequency response,
Yes.
those inverters also work as far as I know in PQ control mode. In P is for if the frequency drops, say at 49.4, then they are
Hmm.
supposed to inject
Yes.
more
Yes.
active
Correct.
power. And Q, if the voltage starts dropping or voltage is too high, then they are supposed to absorb reactive power.
But when actually this what ma'am is saying or what we are saying here is, and when we are talking about a distribution system, and that distribution system, and and especially when we are talking about a microgrid, then that microgrid is a very small part of that grid, main grid. Any loss of load at microgrid will not have a very significant. It's that impact in frequency will be in milli, in that second or third decimal point.
See, again, I'll try to explain you in a different way.
Okay.
Since you talked about microgrid, reactive power is a local phenomena.
Yes.
It's a
Correct.
local phenomena. So you can have a local remedy for it.
Yes.
So
Yes.
a capacitor bank or an inductor would be a local remedy, or a
Okay.
statcom is a local remedy for it.
Correct.
So to maintain it accordingly.
Yes.
So even in a microgrid, this is applicable.
Yeah, that is true. We can use capacitor bank in even in distribution system. We use capacitor bank to boost voltages.
Yeah, I mean to say the active power is associated with frequency, and the reactive is associated with the
No,
voltage.
yeah,
But
that's what I'm
but
saying.
what is
Uh,
told by her is the opposite.
uh, Actually, that's the same thing which I am also trying to say. In distribution system, we cannot say that power is directly related to frequency only. It is depending on both voltage and frequency,
No, it
and
is
it
in her
it will
lecture. No,
depend.
in her
Yes,
lecture she
she
has
has
said
said.
that
Yeah, yeah, correct,
frequency
correct.
active power is associated to the voltage, and
Hmm.
reactive power associated to frequency, which I it's not correct for me. So
She,
she has done
hmm.
that decoupling there.
Yes, I have also heard the lecture.
Probably if you can, communicate to her, or I don't know, I can write, she can clarify. Either
Yes,
I'll
yes.
clarify my concept or she'll clarify the
And
presentation.
you'll see some uh, that what we say, the detail of that is explanation is not given in the video. And you can ask for clarification, that is correct. But it is true that for both transmission and distribution, both P and Q are function of voltage as well as, sorry, I should use something else. Let's say frequency, I'm using FQ for frequency. So they are both function of frequency as well as voltage. Now, which one will dominate? Either it will be dependent more on voltage or frequency. It depends upon the nature of the system. And even in distribution system, it will depend on the configuration on the system topology. It will, it is very much dependent upon that. Size of the distribution system will also matter. And that's why we cannot directly say this. But on transmission system, we can approximate this to this function. This is a function of frequency and this is a function of voltage. We can approximate this for transmission system. But for distribution system, it will depend upon the distribution system, its configuration, its topology, and its size. And you can see, I don't know, in practical inverters, whether it is there or not. But in literature, it is there. The group control is also takes into account this
Correct, correct. Group control is this function.
yeah for
Yes,
so group control is for F. It will be
it's corresponding
P
to P
versus
and Q
F,
is
Q
corresponding to
versus
yes.
V, right? But
Yes,
for
yes.
this, but if you will see literature on distribution system, you will find this PV droop and QF droop also. So both are there. Both are used because we cannot decouple in distribution system. If you will go to the if you go to the power system analysis books, and when you write P in terms of voltage and frequency, when we say this decoupling, we uh, make that decoupling based upon certain assumptions, and those assumptions do not hold true for distribution system. That is why we say that these two are not directly related. In fast decoupled power flow, when we say that yes, here we have P and Q and here voltage and angle. Okay. We say we have only this or theta and V here. So theta is directly related to frequency and this is voltage. So we have here B dash and B double dash, right? So here there is a direct decoupling. The voltage is power is related to only theta and Q is related only to V. But we started with this some A, B, C, D here. And we reached here by making certain assumptions. And those assumptions hold true because of the nature of the transmission system. But these assumptions do not hold true for distribution system. That is my point. And
Okay.
that's why,
Let me
yes,
check also
yes,
this.
sure, you can check and we can again revisit this point in the next class also.
Okay, okay.
Okay,
Thank you.
okay, thank you. Okay, so this is we saw if for positive active power mismatch, the superimposed negative sequence impedance is negative. Negative. So this is an easy question. Which relay will operate under a high negative reactive power mismatch? Now this is the point where what you are saying. Now what will happen here?
P generation is more than P load. Q
Here what
generation
is
is more than Q load.
negative
Negative means
reactive
Q
power
generation is more than
mismatch?
Q load.
Yes, generation
So
is
it would
more
be over
than
voltage relay.
so one. Okay.
More reactive power then means higher voltage.
So this is the this is the PQ reactive power mismatch versus this is the NDZ defined based upon the reactive power and active power mismatch and the limit or the relay which will operate based upon the limit which is hit.
Yeah, this is what I don't understand actually.
Yes, so this comes from mathematics only. Means these formulas are coming directly from. You can do this derivation, and we will reach this point only. And in that's what I was saying here. The decoupling which we are getting here, this is possible because of certain assumptions. And what we are seeing here, this is if we take those assumptions, then we will reach here. And one simple question, not question, observation, and which we all know. What do we say? Means what is power? How do we write power in terms of voltage and impedance? Can you tell?
V square by Z.
Yes, V square by Z. Now, what do you say? Is power dependent only on voltage or only on frequency or both? And this expression is absolutely correct. There is no doubt about this, right? This is universally applicable. So now can we write this? And there are three options. Is it's function only of V. Z is and it's a function of only frequency, let's say. It's a function of both frequency and voltage. From this, can we say something about which of these three options will be correct as per this expression? This is the most simple understanding which we can make.
Function of V.
Only V?
V and impedance also.
Yeah, impedance is there, but impedance is dependent on frequency, right? Because this is R plus J X and X is omega L. And if capacitor is also there, then it is 1 by omega C also. So it's a function both of voltage and frequency. And now if you see frequency, in distribution system, if we talk about frequency, frequency will not change much. As compared to the grid frequency, it won't change much. Right? It will be close to 50 hertz. If it is connected to the grid, island, it's not islanded. Correct?
Okay.
So P is directly proportional to voltage here. But actually it is depending both on voltage and frequency. So
This is part of a standard of 1547 or is it in a book or NDZ?
stand
There is a standard referred no for this or it is part of any book. Then if you can give that reference, that would be
okay,
helpful
I
to
will
this course.
in papers I have seen this. I think this paper or
I can refer IEEE paper and then I will.
yeah, IEEE papers. I have IEEE papers. I will give you reference. Maybe in
Yes.
the reference list I will add. I have
Okay,
papers
just
for
give the
that in
reference.
the folder. I will just
Just
add
give the
that in the
reference.
reference.
Yeah.
Okay.
Okay.
Yes.
Okay.
You can check through that.
I'll go through that. Yeah.
Sure, sure. I have references for that. Even
Okay.
this expression I have taken from that reference only. So we
Mhm.
can go through that. I
Okay.
forgot to add that reference here, but I will
And is
share
it
that. Yes.
okay? Is it part of IEEE 1547 also?
That I will have to check. I don't know.
Okay. Okay.
I
Okay. I
don't
will check
remember
that.
right now. Yes.
Okay. Okay. Okay.
Okay. Okay. So it will go to the, if we go to this negative reactive power mismatch, this will be here, third quadrant, negative y-axis, and it will hit the over frequency relay. And next question is, in the rate of change of phase angle detection scheme, the estimated rate of change of phase angle in case of islanding is greater than threshold, it is less than threshold, or equal, or no change. This is very easy question based upon the passive islanding detection technique. This is what we have discussed. So what should be the answer? Very simple question.
A.
Yes, greater than the threshold. And this is based upon the that superimposed negative sequence impedance scheme. Now, what's the expression for this? We have already discussed. Which one? What's the correct answer here? So K here you can take it as the that window number, kth window that we discussed while discussing the talking about that DFT, how we recurse or iteratively calculate the DFT.
B.
Which one? B.
B for Bob. B.
B for Bombay, right? Correct. So this will be kth minus k minus, so tk minus tk minus 1, correct. So this is previous and this is the current. B option is correct. So if we remove this part, only numerator is there, then it is simply the negative sequence superimposed impedance. And if we divide it by time difference, then it becomes the rate. The limitation of conventional islanding detection techniques. For first, so A, power quality degradation, complex structure, and result in NDZ. So which one is correct?
C.
Result in NDZ? Yes, correct. So there is no power quality degradation here. So this option is not correct. It should not be all of the above. Okay, in signal injection based islanding techniques, injected disturbance signal is low frequency, negative sequence, pulse signal, all of the above. What's the answer? Low frequency, what kind of disturbance will result in low frequency?
So low frequency answer would be A. Small perturbations.
Okay, so this is correct. Even this is also correct. Negative sequence is also a disturbance because it will result in unbalance. And that will also,
Small. So
that,
all maybe all of the above is correct.
yes, all of the above is correct because all these are different kinds of disturbances only. Okay,
Again, I
in
guess this is
which
not a practical use. There is no practical use of active uh,
active
islanding
power
schemes.
injection,
No, active islanding schemes.
yeah, it's better to use hybrid. It's better to use passive or communication based.
No, I don't think that. I mean, as far as I understand, there is no practical application of active islanding anywhere.
Because we are already concerned about power quality, and by using these, we are further deteriorating the power quality. Then what's the use? And this, yeah, that's
Mhm.
not practical. Correct.
Okay.
So in which mode of operation but all these are in literature, so we are just for the sake of uh,
Yeah. This is
information.
gone. The process is, yeah, it has
Yes.
gone through a
And
process.
this is the way the development has happened.
As
So
it has,
someone,
this is how it has evolved. Evolved, yeah.
yes, you can say evolution of these techniques.
Okay.
Okay, so then in which mode of operation the fault current in microgrid is high? Grid connected mode or C, both A and both A and B? So what's the answer?
Grid connected mode. Grid connected mode.
Yes, correct. And why it will be higher in grid connected mode?
Grid will feed the fault. Grid is
Yes.
infinite source.
Yes, and in islanding mode, because we have these distributed generation
We
and
have
their fault
DERs. Yeah, DERs have
is
a limit of
limit
uh,
on fault current.
short circuit ratio. SCR is low.
Correct. So only the grid connected mode. Now, next question. Due to the bidirectional faults, which type of traditional relays are unable to provide safety protection? This is also
Unidirectional overcurrent relays.
yes, correct. Because we need the directional element also. Because of the DERs, there will be current in both the directions, bidirectional, and the overcurrent relay will only detect in forward direction. A disturbance current of ID is equals to 0.05 IDM. Cos omega naught D is being injected into D axis current controller. After islanding, the frequency is present in PCC voltage R. So this omega naught D will be a small frequency, right? It's example of that. We were discussing the previous question was there. What kind of disturbances are injected? So this is low frequency, first one, low frequency disturbance. So by injecting this, what will happen to the overall the new frequency of the uh, quantity which we are measuring at the PCC? Certainly, it will not be omega d. It will not remain as omega d. Right? This is not correct. This should be cos of omega d. So omega d is the disturbance frequency. Omega naught is the fundamental frequency. Which option do you think is correct?
So would you mean by direct access? If it was
Actually,
Q access, then
actually, we have
this
not come up. Means, do you know about this DQ axis?
no, you'll have to. I know, forgotten. Long time back, read.
Actually, we have not
Mhm.
discussed this point. This will come in future weeks, but I will just tell one simple thing that when we are we want to control something. We all know that we use these PID controllers, right? Those are the most simple controllers and which are still widely used in the industry. Although so many sophisticated controllers are there in the literature, but these are still the most widely used controllers. PID. PI or means a combination is also possible, or simply P or D. But these controllers only work when the signal is a DC. Correct? Will this controller work if the signal is in sinusoid? The current voltage waveforms which we get. AC signals. Simple PID will not work. But
Okay.
still we want to use PID, proportional controller. For that there is one frame of reference which we called DQ. There are two actually. One is DQ, one is what we call alpha beta frame. So we will see that in future. But if we give them these ABC parameter, ABC phase quantities, and we transform them to a new uh, new set of quantities, new reference frame, then we get, let's say this is VA, VB, VC, we get VD and VQ here. These are sinusoids, 120-degree apart, or even this can be unbalanced. But these are DC quantities, DC signal. These are constant values. Because this D and Q are 90-degree with each other, with respect to each other. These two are DC quantities. And by doing this transformation, we can still use the traditional PID controllers. That's why we use this. And this theory is also widely used in these generalized machines theory. Actually it came from this technique came from machines when they had to make these MMF patterns, the equivalent resultant MMF which is there in the induction motor, synchronous machines, how to understand those phenomena. For that, a simplified theory was built, which is D-axis, it is DQ theory. It is called stationary frame of reference. And this is not stationary. This is rotating frame of reference. So this is rotating frame of reference and this is stationary frame of reference. So if this is rotating with at the same frequency as this ABC, so resultant is a stationary quantity. And this concept is used in this phase lock loops, where we say that we lock with the frequency of the voltage at PCC. We'll see this again in the future week, 6th or 7th week. This will come again. Both these we will see again. So when we convert these, if here this is current, right? This will be IA, current of phase ABC. We convert them into D and Q quantity. So we call it as direct axis current, and this will be quadrature axis current. So in this ID, if we inject this disturbance, then we will get this. So these are cost terms. So cos A plus B formula you can use cos A cos B. So these two frequency will come. Omega naught is the fundamental and omega naught plus D and omega naught minus D. So these three frequencies will be there in the output. So this is the frequencies present in the disturbed signal, which is available at PCC and which we are measuring. Is this clear? If it is not clear, then we will again come to this DQ and alpha beta.
Yeah, got some idea. Thanks a lot.
Okay. Then next question is, which of the following relays are used for protection of distribution in the net in the presence of DR? It is the same question but in a different form. We have already discussed this.
Directional lower current
Yes,
relays.
B. The answer is B. Now this is also based upon the directional element of protection system. Select the correct pair. It was there in the lecture also. Pair polarizing and operating quantity for a direction relay. So which one is polarizing and which one is operating quantity? So polarizing is also, we can say it's a reference
Voltage is
quantity.
polarizing and current is
Yeah,
operating.
it is also, we can say it is a reference quantity. So why voltage is polarizing?
Voltage is required to determine the direction in
Yes,
the
but
relay.
why voltage is used as a reference? Why not interchange these two? Why not take current as
No, it's
polarizing and
over current relay, no? So you need that as uh, a
no, it's we are talking only about directional element here. Overcurrent is not, we are not talking about a overcurrent here. We can add overcurrent in this, but right now it's only overcurrent. No, sorry, directional.
directional. Okay, got
Yes.
your question. Just thinking.
So actually voltage, whenever fault is there, current, the phase angle and this magnitude both will change for the current. But for voltage, the phase angle won't change much. That's why it is taken as a reference. So reference is something which won't change, right? That is why
Okay, okay,
this is reference and we measure current with respect to this voltage because its phase changes drastically as compared to the voltage. It will change a lot. It can even become opposite. Okay. Next question, angle difference between fault voltage, and this is also based upon the previous question only. Why voltage is taken as the polarizing quantity? Now the answer is very clear, right? What should be the answer? Angle difference between
minimum. So A.
A, yes. The angle has to be very, difference has to be very small. That's why it is polarizing. Yeah, so questions are over. Time is also up. So, do you have any doubt apart from this? We'll carry on in the next week. Those challenges to in that topic, that four things are remaining, that four challenges of uh, protection system, to protection system because of DR integration, that we will see in the next week.
Okay.
Yeah,
Thank you,
next week.
Gagan. Thank you so much.
Yeah, thank you very much for active participation. We will see. We'll meet next Monday, 6 to 8 p.m. Thank you.
Thank you.